Good morning. My name is Mike Willins. I'm Content Director for Advanstar Automotive Group, which includes Automotive Body Repair Network, or ABRN. We are here today for the Why General Sectioning Guidelines No Longer Apply webinar, which is being presented by Jeff Poole of ICAR. Really happy to have Jeff. We've done several in the past. If you aren't familiar with the ones we've done in the past, check out our YouTube page. Everything is up there and archived. Everybody knows the technology changes over time, and things that happened back in the 1980s, and as far as sectioning, some of those guidelines are much different these days. And Jeff is going to walk us through that. We're going to do some polling questions throughout this presentation periodically, so you'll get a chance to participate. Also, as we get closer or throughout the presentation, if you have any questions, go ahead and there should be a little box there for inserting any questions that you might have. And when we get to the end, we'll answer as many as we possibly can. And hopefully that'll take us up to the hour. So with that, I will turn it over to Jeff, and take it away, Jeff.
Thank you, Mike. Always honored to work with you and the folks at ABRN on these webcasts. As we take a look at the presentation, I'd like to stop for just a brief moment here and take a look at the ICAR vision. This is really what guides us in what we do with the industry and the services we provide. The ICAR vision that everyone in the collision repair industry has the information, knowledge, and skills required to perform a complete and safe quality repair for the ultimate benefit of the consumer. This is something that I hold true to my heart. Whenever we're out there repairing vehicles, we're ultimately affecting folks' lives out there potentially in the future, what that vehicle goes through in the future, how it performs in the next collision. We need to keep that in mind throughout the repair process, whether we're right in the vehicle or we're actually facilitating the repairs on the vehicle. So let's jump in and take a look at general sectioning guidelines. And I want to give you just a little bit of history on general sectioning guidelines. It was in the 80s, right around 1984, that ICAR commissioned MGA Research to perform evaluation of automobile collision repair sectioning techniques. This really became the basis for the ICAR general sectioning guidelines. This was conducted on mild steel. So those guidelines essentially include a list of things not to do, basically saying, hey, avoid sectioning in suspension and powertrain mounting locations. Avoid areas with holes that are larger than 3 millimeters. Avoid compound shapes and structures, and avoid areas with reinforcements. In addition, the guidelines warn against sectioning near collapse or crush zones, seatbelt mounting locations, hinge mounting locations, where vertical and horizontal panels meet. So as we take and we kind of compile that, add into that some of the newer technologies that are in vehicles with many of the airbag sensors and things of that nature that are strategically located throughout the structure of the vehicle, not just the frontal sensors, but side impact sensors where we've got 2 or maybe 3 on each side of the vehicle for side impact detection. This becomes really critical in our thought process. We're also going to take a look and add into that the complications of the construction of today's late model vehicles. We'll take a look at that construction to better understand the challenges we face regarding the application of general sectioning guidelines and come to a better realization, better terms with the limitations of where they can or should or potentially shouldn't be used. So, as we look at the vehicle body structure design, this is something that whenever the engineers are designing vehicles, they're looking at a top priority of protecting the occupants. They're building vehicles that are so much safer today than they were in the past. They're performing so much better in collisions. The material content, the engineering designs really do play into that tremendously. The safety systems are right in there helping that as well. We really need to think about that body structure and all the safety systems that are in that vehicle as a concert. That's the way I mentally think about it. That's a concert rolling down the road, and as long as every instrument's in tune and every play is on time, we've got a really great concert there. You get into that situation where potentially there's compromises in any of those systems or any of the structure, Now if everybody has to show up and do their job one day because we're in some sort of a collision, maybe we've got some compromises there that are unacceptable, that are potentially going to impact the lives of those folks in that vehicle. So that body structure design has really come a long ways over the years, and it's that very strategic engineering and incorporation of the material content in that vehicle that plays into the structural aspect. And as we're out there potentially repairing these vehicles, straightening, cutting, sectioning, whatever it is we may be doing to that vehicle, we need to ask ourselves that question over and over again. Is it going to meet the design intent of where it was produced whenever it came off the assembly line? And we look at the front structure of a vehicle and the side structure of a vehicle in this next slide. And the front and rear sections, of course, we've got some opportunity for some collision energy absorption and management to mitigate what makes it to that center section of the vehicle. And the material content today, and we're going to look at metallurgy here very briefly on the next slide, but the material content is far superior in energy absorption in those strategic critical areas over what we had in the past, that it is doing a tremendous job in again, reducing that occupant injury in some of those more involved collisions. Side collisions, a little bit different there. We don't have as much opportunity to have a lot of energy absorption in there, and it's really about getting that energy transferred out and around those occupants, and perhaps through that center section through floor reinforcements and other strategic engineering attributes. But again, we just need to ask ourselves those questions along the way. How are these repairs going to potentially affect the performance of that vehicle in the next event, should there be one? So just a little bit about metallurgy. As we take and we look at steel content in the vehicle, and this presentation was really designed and built around predominantly steel-structured vehicles. Aluminum brings another element into it, and some of the other more advanced materials, some other aspects and considerations on top of what we're going to cover here. So we're primarily looking at steel-structured vehicles in this particular presentation. As we look at mild steel and look at the chart, essentially on the left-hand side of the chart, your IF steels or the mild steels, low strength, they have a lot of elongation property, very ductile. So I'll say it's, to put it in terms of something that's real simple to visualize, more like a rubber band compared to a piece of glass. As you get up towards the martensitic steels, some of the glass out there are very, very strong, but there comes a point in time where it also has it's a lot more brittle. So as we look at the mild steels, a lot of workability there. We had a lot of repairability. Back in the day, whenever we were dealing with these original general sectioning guidelines, whenever we cut a piece of steel that was mild steel and we sectioned it and we welded it back together, we weren't typically losing much strength. In some cases, we were adding strength to that area of the vehicle. Hopefully, we strategically knew what we were doing as we did that, and following the general sectioning guidelines, we were pretty safe on those materials. But looking at the steels that we're dealing with today, as we start to move up that chart into our high-strength steels, our dual-phase steels, trip steels, and up into martensitics, and at the very end of the martensitic scales where the boron alloyed steels live. And we're just seeing tremendous implementation of those ultra-high-strength steels into the body cabin reinforcements on so many vehicles out there that get these vehicles to the performance levels that they're at. So what we, in the repair process, need to think about is, how is our repair going to affect the performance of that particular part, component? Where we've got mild steel and we could cut it and we could weld it back together, and we'd be pretty close, if not exceeding the original design strength of the part, we start getting into some of these more advanced steels, and we find that we don't have the capability of restoring that original design intent in many of the sectioning procedures. We're going to end up with a compromise in there. Now, that doesn't mean there aren't any sectioning procedures for some of these components. There are, but we want to take a look at that from an engineering stance, and that's what we'll do in just a few minutes here. The use of ultra-high-strength steels, as I've indicated, they continue to rise. It's impressive to me as we look at each of the new model year vehicles that are coming out, and we look at the incorporation of these steels. The vehicle manufacturers know the advantage, and that's why they're headed that direction. We see it in the rocker panel reinforcements, the B-pillar reinforcements, roof rail and A-pillar reinforcements, and other key areas of the vehicle. That's not going to change. I believe that ultimately this is a continuing trend as they try to get weight out of the vehicle. I look at the Dodge Dart with the very high-strength steel that they use in the floor pan of that vehicle, And that's an impressive design attribute for that vehicle, and they're looking at how that helps that platform in its occupant protection. Definitely some challenges there for us as an industry in the repair sector. The use of partial hardened steels. This is something that we've seen from a couple of vehicle manufacturers, and it seems to be spreading slowly, migrating out to other vehicle manufacturers, where they have the ability to, in essence, die quench steel, but die quench it and cool it at different rates at different places along the length of that part, so that they can very strategically create a part that's very hard in one area, but I want to say softer and more in tune with the energy absorption in another area. And this doesn't leave us any definitive evidence on that part of where's the transition. Where does that part definitively change from ultra-high strength steel to high-strength steel to mild steel, or whatever it happens to be. I'm just kind of speculating there, and potentially there could be a multitude of different strengths along the length of that part. Again, this is something we have to think about as we're looking at these late model vehicles, saying, can we just assume that that part is the same strength over its length? I recall very vividly many times whenever I was drilling spot welds, and as I transitioned from one part to another, there would be a definitive difference in the way that material drilled with my spot weld removal drill. And now you've got something here where you've got one part that you're drilling, and it's like, wow, things drill pretty easy here, but wait a minute, not so easy down here. And just something to keep in mind as we think about those general sectioning guidelines. It's probably not a good place to apply them. We're seeing incorporation of tubular reinforcements in more vehicles and some of the pillar sections and other areas where they're looking for that key strength attribute. And this can tend to bring in some additional challenges in some cases. Some of the vehicle manufacturers do have sectioning procedures for some of those tubular reinforcements, albeit in many cases they're very strategically located where they'll allow you to section them. But this is an area where taking into account what's that part supposed to do in the next collision, and where is it designed to give or not give, and how is it going to perform as we move forward. Multiple reinforcements. There's still certain applications out there where we've got some internal reinforcements. Generally, when we get into an internal reinforcement, it's going to be a higher strength or higher grade steel, perhaps an ultra-high strength steel in some applications. And as we're looking at the pulling and straightening of components, as we grab that outer piece and we start to pull it and straighten it, now what's happening with that internal reinforcement? Do we know what's happening with that reinforcement? Where's our confidence level that we're actually restoring the internal reinforcement along with that outer body structure or those other components that are damaged on that vehicle? Again, we need to ask ourselves those questions as we look at this and we're repairing that vehicle, to have that confidence that, yes, we have restored things properly. Having a familiarity with the relationship of the different components. How closely do they marry up to each other in that body structure on that vehicle, or is there any space between the I want to say the damaged part that we're pulling on and that internal reinforcement? A lot of the body repair information will show cross-sectional profiles of rocker panels and pillars and other components on the vehicle to give us a better understanding of what's going on right behind the damaged area. Key things that we want to know as we're repairing the vehicles. Energy absorption, I've mentioned that, is one of the key elements that the vehicle manufacturers' engineers look at. How can they absorb that energy, lessen what the occupants feel in that collision? And through the strategic implementation of the materials in the frame rails and the structures, they're putting steels in there that are designed to take and absorb more energy. One of the trade-offs of many of these newer steels, though, is that the work hardening rate of those steels is much higher than the work hardening rate of the mild steels that we had on older vehicles. So this work hardening component of that material, what that does is as that material deforms and it's absorbing energy, it's gaining strength. Now we start pulling on it and we try to attempt to straighten it, and in some cases we find we may have some success on some of the materials that are out there, but we're finding in other cases that there are limitations on the repairability of some of these steels over what we had dealt with in the past. I've seen situations where we're pulling on a frame rail that didn't look like it was buckled too bad. It's got some damage, and we're starting to pull on it, and it's like, man, it's not being too cooperative. We start pulling on a little bit more, and we start to stress relieve it a little bit, and next thing it tears. And we look at the application of heat today. Usually the application of heat is a last resort. You always want to make sure that if you're going to apply heat, you're following the recommendations of the vehicle manufacturer for that particular vehicle. Most of our vehicle manufacturers today have limitations or policy statements against the use of heat on any part that's going to stay in service. So again, that's something that I look at documentation as a key element. We're going to see an interesting development next year in the terms of documentation. We're working on something there. As we take a look at this energy absorption characteristic, how is that part going to respond after it's been repaired if we do a repair on a part? Those are questions we need to ask ourselves along the way. Are we confident that that vehicle is going to do what it's supposed to do in future collisions? So, the effects of the new construction technology, and you're seeing where this is going, the theme of it. And as we look at vehicles from every vehicle manufacturer out there, we're seeing common themes in so many cases. I'm not saying every vehicle is the same, but there are common themes as we look at vehicle construction from a high-level view. We've got those ultra-high-strength steels strategically located so that whenever that vehicle is in a collision, it will strategically deform or manage and transfer that energy through that structure and around those occupants. So this is again where we start looking at a collision damage vehicle. Where's the damage? Where did the energy go? Where was it absorbed? Where was it transferred to? And have we fully identified that extent of where that energy was transferred to so we can properly restore that vehicle structurally, dimensionally, and get it back on the road for a complete and safe quality repair? Mike, I believe we're up to one of the polling questions.
We are, and to what you were just talking about, and the increase in steel strengths and the impact that has on sectioning. One of the questions we have is that have you noticed a decrease in the amount of sectioning being done in your shop? And if you want to say yes, it has been significant. Maybe it's a slight decrease, none at all, no changes at all. And if you don't work at a collision repair facility, you can check that. But just to go along with what you were just talking about in terms of the strengths of the steels and maybe reducing the number of sectioning options, if that's having an actual impact on the shops. So let's take a look at what we found. A lot of people aren't in repair facilities, but those who are, slightly more say, yeah, it is. They are seeing a decrease. So thank you for the responses. So back to you on B-pillar reinforcements.
All right, thank you, Mike. As we take a look at the B-pillar reinforcement scenario, looking at vehicle collisions and vehicle construction over the years, you can definitely, if you were to line up vehicles for the last 20 years, and if you did the same side impact, you'd certainly see a much better performance on our late model vehicles and how the occupant space is maintained in those vehicles. Very strategically, as we saw in the previous picture before the polling question, we had ultra high strength steel in about the upper 2/3 of that pillar, and in many pillars it's ultra high strength steel for the entire vertical height of that pillar. We may find at some of the lower pillar areas down near the base of the seat, there may be some, I want to say, lower strength steels tying in there. And again, that's a strategic engineering attribute of the vehicle, where the engineers are looking at, okay, how's this energy going to be absorbed, a little bit of it, and then where are we going to route it to? We're definitely seeing the ultra high strength steel on the rocker panels, B pillars, A pillars, and this then dispersing that energy, pushing the car sideways in many cases, more so than major intrusion into the vehicle to the levels that we've seen in the past. We don't tend to see as much of what we considered the banana damage. We may still see that occasionally on some vehicles, but usually that's an extreme severe situation where we've got that type of scenario. We still need to measure these vehicles over their entire length on those side hits. We need to determine, again, where's that energy gone to, where was it absorbed, and where are the adjacent damaged areas and dimensional incorrectness in that vehicle that needs to be restored. The Cadillac ATS, was really an interesting vehicle as it's been developed and now being sold out there. And there's vehicles out there that are unfortunately getting in collisions. So they're showing up in shops. We have a vehicle that has 780 DP steel in the front rails. We're looking at ultra-high strength steel in the front rails. We've got aluminum strut towers in this vehicle, and we've got rivet bonding joining some of these dissimilar materials together. As we look at a vehicle like this, and they have very strategically engineered the front rail extension pieces out there as energy absorption components in there, and they do a fantastic job of taking care of a lot of that energy. But once we get back into those rails with any kind of damage, we need to start asking ourselves questions. What are we going to do with them? It's pretty easy on this case. If there's damage to those rails, they're getting replaced. Now, as we start thinking about damage to the structure and structural misalignment, as we look at those dissimilar materials coming together as rivet bonded components, the joining area inspection is going to be very, very important as we look at potential structural realignment. What if the front end swayed just a little bit? What's it potentially done to those rivet bonded joints in there? And as we pull it back, what potentially is happening with those joints? Just areas we want to keep our eyes on and ask those questions to make sure we're not making too many assumptions or just going through that repair without even paying any attention to those items. Complete part replacement is not at the top of my list of favorite things to do as a technician. I am a technician at heart. I enjoy taking stuff apart and fixing it and sometimes putting it back together. It's an area, though, where I look at complete part replacement, and I vividly recall putting numerous complete frame rails in vehicles because that was the right thing to do. There was definitely a pivotal point in my career, and I think that many of us have come to realization with this that are technicians where, man, this stuff just isn't pulling like it used to. They've changed my opponent. That's the mental mindset that I came to as a technician back in 2003 as I was pulling on a vehicle, and it just wasn't responding the same way that the prior model year vehicle had responded. I was successful on prior model year vehicles of that particular model make year. Yeah, essentially, in that model year transition, the material had changed in the frame rail. I didn't realize that at the time. I wasn't as in tune with getting those procedures up front and understanding what my opponent was right up front. Repair planning is critical. Blueprinting that vehicle, getting the information and documentation on how that repair is going to be conducted is critical early in the repair process so we can move ahead with a definitive, clear path of execution of those repairs. Yeah, we are seeing in many cases that certain components on the vehicle need to be replaced in their entirety. It really comes down to the confidence in knowing that that part is then going to respond as designed with no compromise. And whenever we think about the airbag deployment timing and the critical nature of that, there can be no compromise. I don't want to have to take that to court and try to defend it if I've engineered a compromise into that vehicle and I didn't know what I was doing. I'm not an engineer. So we look at the OEM procedures that apply to the vehicles. We look at what's going to be right for our customer and their lives in the future as we repair these vehicles. Very, very important. There are situations where perhaps part of an assembly could be installed in a vehicle, and I like to approach collision repairs with the mindset of the least intrusive repair that's going to get me the right result. Let's do our research up front and see what's appropriate for that vehicle. I've seen situations where complete frame rails were put in vehicles where perhaps a partial installation might have been more appropriate and less intrusive. I don't particularly enjoy drilling out extra spot welds just for the fun of it. I enjoy welding a lot, but the drilling out of the spot welds is not so much fun. So, again, this is where we want to make sure we're researching and identifying, is there an appropriate partial part installation? And this particular photo is really, really an interesting photo. This is actually a Honda Accord. And Honda has procedures on some of their vehicles where you can put the front rail in as a partial replacement part from the firewall forward. Or you can put the complete assembly in clear down onto the floor. You start thinking about the intrusiveness of putting the whole rail in, and certainly if there's damage that warrants further back into that rail, putting that whole rail in, do what's right for the vehicle, put the whole rail in. But in situations where perhaps the damage is limited to the front portion of that rail, and there is no definitive remaining damage further back in the vehicle that can't be removed by straightening, then we've got that opportunity to put it in. Document it correctly. This is not a sectioning procedure we're looking at right here. This is a partial replacement at factory seams. And this can become an important piece of that documentation on that vehicle should anybody question the repairs. because if you were to take and put down that we section the rail, you put this in, you didn't technically section the rail. So again, just a finer point there that I've seen become a point of interest, I'll word it that way, and concern on a few estimates that have been reviewed over the years. Sectioning. Now, partial replacement of parts at factory seams, full part replacement of factory seams, essentially we're removing spot welds, we're removing whatever type of fasteners are holding that vehicle, if it's rivets and adhesives or something of that nature, and we're replacing that entire part at some factory seam location, if you will. Whereas sectioning is a little different. Of course, sectioning, we're cutting a part, we're creating a cut line where there wasn't a cut line before. We need to be surgical. As an industry, as technicians, whenever we're doing the repairs on today's vehicles, the build tolerances of today's vehicles are far superior to anything we've ever seen in history. I think back to my beginnings, and whenever I pulled a fender off of a vehicle and 17 shims hit the floor, it didn't matter if you added a few or took a few out. It really wasn't going to make a big difference in how that vehicle performed in the future. Ultimately today we're seeing where in many cases there are no shims, and we've got tolerances that are down at a millimeter or less from some of the vehicle manufacturers as they're rolling off the assembly line. Those build tolerances play into how that vehicle manages collision energy whenever we're dealing with severe collisions. And so this is something that as we're putting those vehicles back together, it's critical that we're getting our repairs to mirror, if you will, to some degree, where that vehicle was built. So I think about the general repair tolerances that we've accepted in the industry over the years of plus or minus 5 millimeters for a full frame and plus or minus 3 millimeters for a unibody, and we may find limited applicability of that on many of today's vehicles due to the design attributes of the vehicles dictating that we get things put back together tighter than they were. Measuring of the vehicles is critical. I've had a number of conversations with folks over the years. Sometimes we'll get telephone calls, and many times the questioning goes along the lines of, well, did you measure the vehicle? Yeah, we measured it. Do you have the printouts of the measurements? Nope, we don't have the printouts of the measurements. Wow, that puts us in a tough situation where we didn't document what we did to the vehicle, where we started and where we ended up. Again, it's going to be very critical that as we look at any of the part replacement or sectioning procedures, we're making sure that we're measuring that vehicle thoroughly, we're restoring the dimensional accuracy to as best mimic where that vehicle was originally built. And that becomes a bit of a challenge for us as we're out there, as we measure vehicles. I always enjoyed measuring the vehicles and even measuring areas of the vehicle that weren't even damaged. And it doesn't take very long to do this, but that gave me a better sense of what type of build tolerances are we seeing off the assembly line. Now, I worked on a lot of Hondas and a lot of GM products and a lot of Chrysler products and a multitude of others over the years, and as I saw the same model come across my bench, I would take and gain that familiarity with the build variations, if you will, and then it would give me a better comfort level as I was repairing other vehicles to take and say, you know what, those vehicles are built pretty tight, and I'm seeing a variation here in my numbers that I'm not comfortable with. Or maybe I would come to the conclusion that in some cases there was a little bit of additional tolerance in some vehicles off the assembly line, and I'm comfortable with a couple of millimeters here or there that aren't going to worry me too much. And again, these are things that we as repair professionals have to ask ourselves along the way. How's this vehicle going to respond? The sectioning procedures. It's not about personal choice. It's not about how I want to do it as a technician. We really need to look at what's the right way to do that repair. So I discussed sectioning versus partial replacement. We've got that sectioning as a part we're cutting where there wasn't a cut line before versus the partial replacements going in at that factory install point, if you will, albeit it may not be the complete part as serviced by the vehicle manufacturer. Hopefully we're pretty comfortable and clear on that. Make sure you're documenting your repair orders accordingly. If you're sectioning, certainly put it down as sectioning. If you're doing a partial replacement, document it accordingly. So what are some of the sectioning decisions? Now, those are some of the things that we really need to take a look at carefully is, what drives us to say, yes, we're going to section this. Well, at the top of that list should always be the OEM repair procedures for that particular vehicle. That should be number one at the top of our list. Vehicle manufacturer policy or repair statements or guidelines are always right up at the top. And then as we take and we kind of go down a mental list of things to put into that, We look at the complexity of today's vehicles, the material content, the build stack of what potentially is inside, and the vehicles need to collapse in a specific manner. Sectioning of the parts on a vehicle can potentially affect how that vehicle is going to manage that energy in the next collision. So if we're going out there and we're sectioning a part and we do not have a documented, engineered, supported procedure, and that puts us in a very precarious position so far as liability goes. The technician, the shop, ultimately shoulder that responsibility for that repair, and rightfully so. That's an area where I am now the doctor repairing that vehicle. And we really need to think of ourselves that way. We are professionals out there repairing these vehicles, and people's lives are at risk in the performance of that vehicle in the future. So as we look at where do these procedures come from whenever we look at sectioning, we really need to look at engineering. And so the vehicle manufacturers, in many cases, they'll take and they'll engineer procedures. They'll do component testing, part testing. They'll then do some computer modeling simulated crashes, and then they'll do real-world crash tests to validate what they've got in that repair. And that gives them the confidence. And this is where it's in some cases challenging to take and say, well, I want to take and section something. Now, how do I know if I don't have this type of validation behind it? How do I really know what it's going to do? Or if we potentially engineered in a compromise that may make the difference between the airbag deploying on time or not deploying on time. Looking at the side airbag deployment timing, we're talking thousandths of a second of timing is what it comes down to. Not 20 thousandths of a second, not 10 thousandths of a second, but down to thousandths of a second in some cases on a side impact. For that airbag to literally be out there and in place or not be on time, and the occupant sitting in that vehicle potentially incurring injury above and beyond what they might otherwise. As we prepare for sectioning, I mentioned measuring, structural realignment, the correct anchoring of the vehicle, the correct identification of the full extent of damage, finding where our good anchor points are, finding where potentially structural reference points are out of dimensional tolerances in the adjacent areas. Again, this is a critical piece of getting that vehicle restored properly, getting it mounted and clamped. In some cases, we may find that our 4 pinch weld clamps alone are not adequate on the vehicle. We may find we need to invoke additional supplemental anchoring in different areas of the vehicle to assist with keeping the good parts of the vehicle where they belong while we take and we pull and realign some of the damaged areas. And in many cases, we're probably going to be replacing some of the more involved damage on some of the structural components on that vehicle, but we need to look at pulling on and realigning so we can get the adjacent, the indirect damage out of that vehicle structure. That way when we do replace, whether we're doing a full replacement of a part or if we're sectioning a part, we've got that foundation where it needs to be, and we can bring our replacement parts into the picture and get those installed properly so that that vehicle will perform properly in the future. And as we look at collision repair and the repairs that are happening out there, something else comes to mind for me, and it's something that's a little further down in the repair process, but that's corrosion protection. Corrosion protection is a concern and something that we need to keep in mind with any of the repairs that we do. I've seen some really great repairs done with some really great welding and craftsmanship going into it, but sometimes we might forget about that anti-corrosion compound, and hopefully we don't. Hopefully we've got that as part of our repair process, and it's in our work stream flow at some point where this is done and definitively identified and checked off to make sure that we haven't accidentally forgot to do that. So let's face it, corrosion is a very powerful process out there, and it can potentially lead to structural degradation, and nobody wants that. Real quick, we'll take a look at locating sectioning cut lines. Different vehicle manufacturers have different recommendations for how they would like you to perform the sectioning joints on the vehicles. And it's not really something I look at as a personal preference on my part. This is the engineered procedure. This is how we should do it. So first off, as we start to identify those section cut lines, hopefully we've got the documentation, we've got the supporting procedures, and now we'll get in there and we'll start measuring. I've seen it, and it's kind of interesting. On some of the procedures, they'll give you a sectioning cut line location that maybe is measured from the front of a frame rail. Now, I stop and I scratch my head because maybe I've got a vehicle that's got damage on the front of the frame rail, and I may have pulled on it and restored the adjacent dimensions, but I might not have the front of that frame rail completely out there where it belongs. And so that might not be the best place to measure from. So there, in which case you may have alternative measuring reference points and relationships, but generally we'll take and use our replacement service part to then draw some additional relationships and references from the front of the rail further back on the rail to another reference point, and then do our reference measurements to the cut line forward of that. Everybody's heard the adage, measure twice, cut once. I like to have another set of eyes on it too before I make those cuts, just in case I'm not thinking too clearly. I might have missed my morning coffee or something, and once you cut that part, that's kind of devastating if you made an error and came up short. So good measuring, using tape measures, tram bars, templates work out real well. Whether you're using masking tape or using some of the anti-spark papers or something of that nature, I found in some cases that some clear, thin plastic and something that's substantial enough that it doesn't wad up on you, but kind of like what we use for face shields and things of that nature. I found that comes in handy for making some of the templates out there where I can then lay it over and then draw reference holes and maybe drill reference holes that align with reference holes that are already in the structure of the vehicle, and then using that to kind of transfer things over. Whether it's the use of templates or what we're seeing in the lower left picture there, they've overlapped the service part and they're scribing a line for the cut. The lower right is called the cut and join, which is very popular on many of the Asian vehicles out there and some of your European vehicles as well. We're seeing that gain popularity even on the domestics, as we slowly see the butt joint with backing kind of fade away. It's still a valid joint on many vehicles, but the cut and join then creates an open butt joint. It's interesting as we look at that open butt joint type sectioning procedure. Your welding skill set to weld 0.65 to 0.7 millimeter steel across a rocker panel, a sill panel, across the dog leg, across a sail panel on a piece of outer body sheet metal, you have to have superior welding skills. Now, I know many of you do. And as you take and you look at that joint, open butt joint, you're looking at basically those two pieces of metal with a small gap between them as we come across there with our welder to weld that up. We're finding many of the vehicle manufacturers do call for MIG welding here. You may find that MIG Brazing is implemented by some of the vehicle manufacturers on some of those welding procedures. So again, critical we get those sectioning cut lines located accurately. You may find that in some cases vehicle manufacturers have some general recommendations for some of the outer body sheet metal applications where you've got unicide damage and they say, well, you can section in this general area, or they may say you can section per the damage on the vehicle. In other cases, they may have very specific cut lines called out. So again, this is where we really want to rely on those OEM resources or other information resources that draw on the OEM resources to identify what's right for this vehicle, get that to the technician. Hopefully the technician, again, has the skill set to execute that repair properly and get quality welds in there so we've got good structural integrity. I think we're up to the next polling question there, Mike.
Yeah, we are. And, you're talking about welding, and we'll get into this spot welding poll question real quick. Before I do that, we've got about 15, 20 minutes left. So if anybody has questions, hopefully we can get to the end and have some time for some Q&A period. Also, just a reminder that this will be archived online, so you'll get access to that when we're done. But to the polling question, how frequently are you performing spot welds for repairs? Are you doing it weekly, monthly at most? If you don't own a spot welder, you can check that. And if you don't work in a collision repair facility, you can add that. So with that, let me check the results. Again, high number of that don't work, but those who do are performing spot welds weekly for the most part. So thank you for the responses. And we'll move on to spot welds. All
right, as we take a look at spot welds, that's predominantly the way the vehicle manufacturers put the vehicles together today. There are some out there that are coming up with alternatives to that, but it's the mainstay where the equipment essentially uses the resistance of the steel. As the spot welder contact tips come together, tremendous amount of pressure and current are applied, and we get the formulation of our weld nugget, if you will, but there's no addition of material. So we get in there and we look at removal of these welds. We want to, again, be very surgical in the removal of the welds. I try to think about, whenever I'm taking the vehicle apart, how am I putting it back together? That's really why I want to know how I'm putting it back together before I start taking it apart. So I'm prepping along the way. That way I minimize my rework or extra work as I'm going along. So very strategically, whether it's drilling the spot welds out or grinding the spot welds away, the belt sanders seem to be working out very, very well in many applications out there, catching on in popularity. We just want to make sure we're not creating more work for ourselves along the way. There's a tremendous increase in the I'm going to say the recommendations for the use of, and in many cases the requirements for the use of resistant spot welding in the repair of today's vehicles. The equipment has evolved tremendously over the years, and in many cases we have the capability of putting that vehicle back, if not as built, very, very close to as built with the equipment available. Weld bonding is something else that we see from some of the vehicle manufacturers, and this is something where we want to make sure that we're comfortable with weld bonding if that's called for in the repair of the vehicle. Of course, that adds challenges to disassembling the vehicle as well as reassembling the vehicle in some cases. The WCSO4 class that we have, resistance welding, it goes into a lot of depth on these different areas, might be worth checking out. There's a Ford weld bonding procedure that's been around for a number of years where we're actually going MIG welding and adhesive bonding on the same flanges, a little bit of separation for that adhesive from the weld site. Wouldn't want to have any contamination there. So as we're repairing some of their vehicles, you'll find this is called for periodically. As we're out there doing our plug welds, how many of our technicians are proud of their welds? How many of our technicians would take and say, I want to show this off in Times Square, New York on New Year's Day? This is where we need to be as an industry, have pride in our work so that as we go out there and we're making those welds, we're really proud of what we're doing. Hopefully we are. We are technically, in many cases, MIG welding. We use the term MIG welding, metal inert gas, when in reality, if we're using a mixed shielding gas with any active component, it is MIG welding, metal active gas. We draw more attention to this in our newer training courses, just so that the industry has that comfort level with the fact, it's not something new or different. It's just what we've been doing for many, many years. We've accepted it as MIG welding. If you're MIG welding, you're using a totally inert gas, and typically we MIG braze, and we MIG weld aluminum with 100% argon shielding gas, which is totally inert. But most of the time when we're MIG welding steel, we're actually MAG welding it. A few of the vehicle manufacturers call for MAG welding in their body repair procedures. You may find where they have specific shielding gas mixes called for due to the attributes of that, along with the weld puddle formulation and perhaps a unique welding wire that's spec'd out. MIG Brazing, I mentioned that. We do have an online course on MIG Brazing that can help you understand that process a little better. We also touched on it in a few of our other newer courses. This is something we're seeing gaining some popularity slowly. It's a lot cooler process. It's about 1,000 degrees cooler than MIG welding whenever we're MAG welding when we're using steel. So this is an area that we're seeing in vehicle construction and a few of the repair procedures. We need to be ready to do it if it's called for on that repair. We're seeing a lot of laser welding from vehicle manufacturers. This is not something that we can reproduce in the collision repair facility, but again, we have to deal with it so far as removal and then reinstallation using resistance welds or MIG welds or rivet bonding or weld bonding or whatever is called for from that specific vehicle manufacturer. Wow, that new Corvette, it's something else. I'm really liking it. We're going to see those out on the road soon, and hopefully they'll be showing up at your shop and repairable. They've built in a lot of repairability to this vehicle. So we've got some additional information on the new Corvette Stingray and the new 14 course, which is launching on December 16th. So perhaps check that out. A lot of other good information in there as well. Something else that's rather new, and we go into a little more detail in the new 14 course, is the Honda Body Repair News. If y'all haven't checked that out, I've actually got a separate monitor up here with the Honda techinfo.honda.com website pulled up, and there's some really great info there. This is not buried in their website where you can't get to it. It's free. It's something that's out there. There's a multitude of these. Some really, really good in-depth information about repairs to Honda vehicles. So something you might want to look at. One of the pieces that was really of unique note to me, and again, I love welding, it's kind of therapeutic for me, is the use of the selection of electrode wire whenever you're doing your MIG welding. This is something that Honda has very specific recommendations based on the steel stack in that vehicle. So it's something we ought to take a close look at. I love welders. If you haven't gotten that by now, I really enjoy going out there and pulling the trigger and seeing that weld puddle formulate and become one with it. Smart welders are something we're looking at to help increase that production efficiency. Going out there and having to swap out wire and gas bottles and stuff like that so I can change process from one to another is just no fun, and it's not real efficient. So we're seeing this start to take place. Pulse welding seems to be very favorable for aluminum and MIG Brazing. So again, if you're a good welder, it can make you a great welder. Moving ahead from there, liability. That's really what it comes down to. At the end of the day, who's responsible for that repair? We want to make sure that we're comfortable with the repairs that we do on the customers' vehicles. We want to make sure we've got the supporting documentation, so if there's a question about why we repaired it the way we repaired it, we've got that documentation to support it. We're not just saying, well, that's the way we felt like doing it, or that's the way we've always done it. That's not going to hold up too good if you have to get involved in any type of legal proceedings on that vehicle, and hopefully you never do. SPS 05 has been updated this past year to be a more comprehensive qualification. That is a steel sectioning qualification where you actually work on a rail that's made of 16-gauge steel and 22-gauge steel with a multitude of different joints that are representative of joints used on today's vehicles. It's a challenge. Are you up to the challenge? That's one of the most fun events I've ever been involved with as an ICAR instructor and weld facilitator. This is something that folks that go through that particular qualification, at the end of the day, they walk away with such an appreciation for the coaching environment that we provide at those events. I think that just about everybody out there, at the end of the day, they're like, wow, that wasn't what I expected, and that was very, very worthwhile investment. WCS 03 was updated in 2012 to take and incorporate 16 and 22 gauge metal. You certainly want to be able to pass WCS 03, and you want to have passed it before you get into that SPS 05. Again, it's challenging whenever you start looking at that 22 gauge and those up and butt joints and things of that nature. Are we up to the challenge? Hopefully we are. So how are you going to decide? SPS 10 and 11 recently launched here in November. SPS 10 deals with replacement of steel uniside parts and unibody parts, and SPS 11 deals with sectioning more in depth than what we've covered in the presentation today. I wish I had 4 hours to spend with you all here. My energy level can go for 4 hours this way, and it's just so exciting where we're at. Yeah, the challenges are going to continue. We need to continue to move forward in a positive manner to take and meet those challenges. ICAR's working behind the scenes, and we've been working on this for a while. We're going to continue to work on this repairability and technical support initiative where we work with the industry, the equipment manufacturers, the vehicle manufacturers, and bring all of this together to try to fill in some of the gaps and some of the information that we need to repair these vehicles properly. If you have opportunity to get involved with this, please do.
Good information, Jeff. We got our last polling question. And actually, I'd be kind of curious down the road maybe to get your opinions on this, Jeff. What is your opinion on how construction materials will change in the future? Do you think they're going to be stronger and lighter weight steels will become more prominent? Do you think aluminum structures are going to increase significantly? Use of carbon fiber frames are going to increase? Do you think all of the above? Just click the answer that you feel is most appropriate. And let me push the results here. All of the above. So lots of changes expected across the board, and we will move on.
So the search continues. Right now, the steels that we have in today's vehicles have been in development for many years. They're continuing to work on newer steel formulations that will be in tomorrow's vehicles. It's going to continue to evolve. Steel, absolutely. They're going to continue to evolve the steels. Aluminum, oh yeah, we're going to see some more aluminum in the future. Carbon fiber, I think it's a little further out on the radar. We're going to see some carbon fiber. We're going to see some interesting developments there as we move forward. But I don't think it's going to become quite as prominent as we're going to see with steel, the segment leader, aluminum number 2, and maybe carbon fiber coming in, as we saw in the responses there. So we need to be ready ultimately for this. And this is kind of neat. This is that little BMW electric vehicle. Yeah, it'd be kind of cool to see how these do out there on the roads of America, and see what happens whenever they show up in your shop. You will need some very specific training to repair this vehicle. New 14, we've got a little more information on that one as well. The vehicle manufacturers are not stopping. They're not going to stop for us. They're not going to wait around. We need to be proactive and stay ahead of the curve as best we can. There's over 240 industry-wide debuts, redesigns in the next couple of years coming at us. It's a huge, huge ramp ahead of us. The insurance companies, the vehicle manufacturers, large collision repair facilities look very, very seriously at Gold Class and the value it brings, the training, the confidence that it brings to that facility in the repairs. Certainly something that many shops are looking at, and hopefully you will also. Who's going to test your work? At the end of the day, who's going to put it to the ultimate test? Somebody's family? How's it going to do? General sectioning guidelines may have limited applicability to cosmetic or mild steel or lower strength panels. There may be some general allowances in some cases from some vehicle manufacturers, but when we start getting into the structure of that vehicle, we want to know 100% for sure. We've got that confidence that, yes, it's going to do what it's supposed to do on time. That way that family gets home at the end of the day, and everybody's safe. OEM procedures, repair blueprinting and planning, this is all critical as we look at what we're doing with these vehicles. We're seeing limitations on sectioning. Typically that starts at about 600 megapascal and above. It's not as common anymore. As we look at limited application of general sectioning guidelines, we look at it, what we've covered here today, and how that really lends itself to where we started back in 1984 with this, and it's just not as applicable today as it once was.
And we made it. Thank you, Jeff. We got about 5 minutes for questions, and I'm going to sort of jump around on some of the questions that we have. And for everybody listening, we have a queue of questions, and we've got 400 people, or roughly 400 people, that are actually listening in. So there's quite a few questions. I'll get to what I can, and Jeff can get to what he can. And if for some reason we don't get to your question, perhaps we can follow up afterwards. So with that, on question number 13 here, Jeff, are there any tools or gauges out there to help a tech determine the relationship between an outer panel and reinforcements, distance between the two, to aid in repair planning?
Got it. I look at information as a tool. That's what I look at. To take and say we've got radar or sonar or X-ray or something like that, not so much. Perhaps a bore scope. I personally own a bore scope that allows me to go in through any existing feature hole or mounting location or something like that and see what's behind there. Is that something that shop might consider? They might. Otherwise, you're guessing. Certainly, the body repair information for that vehicle is going to be a critical tool. I think the internal knowledge base of a shop as we work on vehicles, gaining a better understanding and perhaps sharing that knowledge internally is something that's critical, where we've got that experience of one technician to another, one estimator to another, and what they've seen on that vehicle. But the bore scope comes to mind, the service information comes to mind, where they've got the cross-sectional views of some of the vehicle structure.
Great. Moving on, question number 10 from Thomas. What's the recommended squeeze pressure needed for ultra-high strength steel?
So there's no one-size-fits-all answer here. Generally what I've seen in the trends and the recommendations from vehicle manufacturers are, yes, ultra-high strength steels. They do recommend some pretty high squeeze pressures. I'm not going to stick a number out there. This is one that you need to look at the specific repair information for that vehicle from that vehicle manufacturer as to what they want applied, because you don't just have the ultra-high strength steel. generally you've got a stack of steel there that may incorporate anything from mild steel to high-strength steel to some blend of advanced high-strength steel right up to ultra-high-strength steel. And they're looking at that entire panel stack essentially in most cases where that's coming together. So for me, just to stick a generalization out there, that would be dangerous.
Great. Question number 20 on the list is from Tim, and I think he's asking for some clarification. Did you say there are OEM-approved sectioning guidelines for ultra-high-strength steel? And
from some vehicle manufacturers.
Okay.
There are a few vehicle manufacturers that have sectioning procedures on ultra-high-strength steel parts. Not very many have sectioning procedures for ultra-high-strength steel parts. So this is where you'll need to take and look at very specifically up front what's allowed on this vehicle. And this is another area where I'm not going to take a procedure from one vehicle manufacturer and say, well, they do it over here, so I'm going to do it on a different vehicle or a different brand. I'm not going to universally apply that. Even in situations where I don't have procedures, I'd rather take a safer route out. And if I don't have approved procedures where we're dealing with supported documentation on a vehicle, it's got high-strength, ultra-high-strength steel in there, we're probably better off as a best practice looking at part replacement.
Good. From Dave, question number 17, is structural laser welding still being used?
There's some applications where vehicle manufacturers have it in the manufacturing aspect of the vehicle. So I don't know how to take that any further than that.
Okay.
I don't know how much more widespread it's going to become.
Okay. Question number 26 from David. Are there any color-coded manuals showing the different types of metals used that help in the repair planning?
That's always been one of my my dreams out there, was that whenever I started taking panels off, they'd be color-coded, and I would think red would be no, don't do this. But that's not happening. And in some cases, yes, there are. If you take a look at the techinfo.honda.com and look at those body repair news publications, you'll find they've got some really great color graphics in there of some of the body structure. I do not know of a compilation of this information in one resource, and maybe that's something we'll see in the future somewhere. I'm not sure.
Sure. And one of the questions that just came in is number 25, referencing the OE sectioning procedures and where are the best places to get some of those OE sectioning information.
That becomes one of those business decisions that a facility has to make on where are they going to draw from. Yes, certainly the vehicle manufacturer, perhaps some of the independent resources that are out there, and I'm not going to go brand specific, but there are a number of companies out there that are taking, and they've developed relationships with the vehicle manufacturers to take and provide the OE service information through their portals. And, that's certainly a consideration for shops and facilities to pursue.
Okay. And I'm going to ask one more question, and I love it because it's coming from another part of the world, which says that we're reaching a lot of people. This one's from Mark. It's number 28 from ICAR, Australia. MIG Brazing causes issues when performed incorrectly. For example, it gets too hot. How do we ensure that the process is right, especially in ultra-high strength steel components?
Yeah, thanks, Mark, and good day to you down there. Good to see you chatted in or sent that question in. That's huge. That's something that perhaps we'll see additional training developed here in the future on MIG Brazing to take and address that. Taking and looking at that MIG Brazing process, it's easy to do incorrectly. And it's not a difficult process to do correctly if you are in tune with it. But this is where really looking at what type of recommendations come from the OEMs, what's the expectation of this, understanding those expectations is a very critical element. And I found that in many cases with the MIG Brazing, they're finding that the pulse welding equipment seems to be a little more favorable to getting that done correctly over incorrectly with a typical short circuit machine. So that's something that we need to look at. We are, I'm going to say, perhaps going to see something in the future from ICAR. Maybe other folks out there will be pursuing some of that as well. I would certainly encourage folks to take a look at the ICAR online MIG Brazing course. Some good information in there.
Thank you very much today, Jeff. And I want to thank everybody for attending. As I mentioned, we will have this archived, and if being registered, you'll get a notice when that archive becomes available. We'll also post it to our YouTube channel so that if you're looking for ABRN magazine, it's all one word. That's how we have it in YouTube. You can find us there. And all the other past ICAR training that we've done and other webinars that we've done. So, Jeff, I want to thank you one more time, and I hope everybody has a great day.